All right, we are going to talk about acids and bases and conjugate acids and conjugate bases. So, in an acid-base reaction, we have two things that react together, and then we have two products. And those products in this particular one are going to be Cl- and H3O+. Now, most acids have an H at the beginning of their formula, okay? This has an H here, and this has an H here, which that's kind of a problem here because both of these have an H. And we can't have two acids in a neutralization reaction. So that's not the best way to tell if it's an acid or not, especially because not all acids have H at the beginning. Most do, but not all. So the best way to tell if something is an acid versus a base is to look at what they turn into. So HCl turns into Cl-. Now, how does it turn into Cl-? Well, it loses this H, and that H is also an H+. So when it turns into Cl, it loses that positive charge, so it turns into Cl-. So anything that loses an H+ is an acid. And since HCl turns into Cl-, that means the Cl- is the conjugate base. Okay, so whatever the acid turns into is the conjugate base. Now, H2O turns into H3O+. Now, the way that H2O turns into H3O+ is that it gains an H+. Okay, as you can see here, it's H2, and over here it's H3. So it gained an extra H, and it gained that plus. So it gained an H+, meaning H2O over here is the base, and H3O is that conjugate acid. Okay. Now, the reason that the acid turns into a conjugate base and the base turns into conjugate acid is if we flipped the reaction around. So if we had, instead of the products being over here and the reactants being over here, we switched and we had H3O+ over here plus Cl- over here. And then our reactants on the other side, HCl plus H2O. Then, since I should have put a double-sided arrow up there, but these are double-sided arrows, which means it's a reversible reaction. So since we have the reversible, or the reverse reaction, the H3O+, now again, we're going to look at what it turns into. Okay, the H3O+ turns into H2O, and the way it does that is by losing an H+. So that means the H3O+ is the acid, and the Cl- turns into HCl, and it does that by gaining an H+. So that means the Cl- is the base. Okay, so since we have HCl as a reactant up here, and it's an acid, it turns into a conjugate base, the Cl-, because if we flipped-flopped the reactants and the products, the Cl- would then be the base of the reaction. Okay, so that's why acids turn into conjugate bases, and bases turn into conjugate acids. Okay, and that's all.